I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss 3 questions which are top 20% difficult questions on any competition like SAT, AMC 10, 12 or even in Olympiad, junior level. The idea here is to share with you how should we prepare for such exams and consistently perform well. So we'll take up a concept. Based on the concept, we have selected some questions which are popular and they should help you to perform better and be right on the top. Very first question is before you, where we are talking about a Ferris wheel. Well, these questions will be solved without calculator. The question here is, Ferris wheel of radius 24 feet revolves at a constant rate of 1 revolution per minute. How many seconds does it take for a rider to travel from the top of the wheel to a point 12 feet vertically below the top? 4 choices are given to you. We'll discuss the strategies. Now, these strategies can be applied in many similar situations. So here is the next example where the strategy can be applied. So the question here is, a windmill has its center 6 meters above the ground and blades 2-meter length. A point P at the tip of the blade makes a complete rotation in 12 seconds. At what time is P exactly 7 meters above the ground? So you do see a similarity between this question and the previous one. While these questions have actually come in past test papers, I've only made a slight difference to give you a flavor. You get the idea. Because questions are never repeated. You always get new questions. We should think broadly. How do we tackle these new questions and be right there on the top, as most of my students are? Now, the idea here is, in case you want to get guidance from me, you can always send an email on the address given. Now, we have another question here, which is looks different, but is actually the base for the solution of the above questions. Here, we are talking about angle measurements. So the question here is, the terminal arm of an angle theta lies in quadrant 3 on the line with the equation 3x minus square root of 3y equals to 0. Find the value of theta. So here we are talking about finding the value of theta. In the last 2 examples, we were trying to find out when a person will reach a particular height. If you closely connect them, it is basically finding theta in the first 2 questions also. Once you know the angle of rotation, you know the total time taken for one full circle, you should be in a position to get your answer. Perfect. So the key is to understand how do we calculate angle when rotation is involved, and therefore I've taken this very simple example to illustrate, and that is how we teach, right? So we build on concepts. Once you understand the concept, it can be always applied, and there you go. You can nail the top 20% questions with ease. That's the whole idea, right? So let's talk about this problem first. Understand the concepts, and then those concepts will be applied in the first 2 questions. Perfect. So let's try to see what are we asking for. The terminal arm of an angle theta lies in quadrant 3. So first you should understand what is quadrant 3, right? So here is your coordinate plane. Quadrant 1, right? This is quadrant 2. This is quadrant 3. and that is quadrant 4, correct? So the terminal arm lies in quadrant 3 on the line with the equation 3x minus square root 3y equals to 0. So that's a direct variation of something, right? It goes through the 0, and therefore the line could be drawn something like this, right? You get the idea. We are saying that the point lies in quadrant 3 means somewhere here the point lies, but it is on the line. Now the question is find the angle theta. So the angle which you are interested in finding basically is the principal angle, right? That one, correct. So obviously the angle is more than 180 degrees, less than 270 degrees. You get some idea about it. But here there are many choices which give you the angle, right? So how do we find this angle? Well, let's find the related angle. This angle here is called the related acute angle, right? So let me write down here the name. This is called related acute angle. Normally, we represent this by angle beta. Now, this angle is same as that angle, vertically opposite, so that is also beta, right? So the acute angle is always measured with the horizontal. It is always positive, correct? As shown here in this situation. Perfect. Now, we have to now figure out what could be the points, right? So, well, the equation given to us is 3x minus square root 3y equals to 0. So, I could isolate y. So, we could write square root 3y equals to 3x, or y is equal to 3 over square root 3 x, which is also same as square root 3 x. You get the idea. So this equation of line actually gives you the gradient or the slope, right? So what is the gradient or the slope in this case? Well, the gradient is you can say m is square root 3. So gradient of square root 3 means there is a slope of rise over run, right? So if I actually look into this triangle here, drop a perpendicular, let's say, if I drop a perpendicular from here, let's say, in that case, we have the side as square root 3 and that as 1. So that is the ratio. We are basically finding the angle beta. Now this reminds you of a special triangle, correct? Does it? So this reminds you of a special triangle. And what is that triangle? That is 30, 60, 90 triangle, correct? So in a 30, 60, 90 triangle, you know that the hypotenuse is 2, adjacent side is 1, opposite side is square root 3, and the angle is 60 degrees, right? So from here, you get that the angle beta, the related acute angle, should be equal to 60 degrees. You get an idea. So we just found the angle using the concept of special triangle. So once again, let's get into this diagram once again, right? So what we did here is something like this. We had this, so we dropped a perpendicular. Let me use a different ink here. Right? And we are saying that this is square root of 3. This is 1. And that will be 2, right? You know a special triangle. So this is our 30 degrees, 60 degrees, 90 degrees special triangle. Knowing special triangles is key in getting good marks in all these competitions, right? So we're looking into SAT, AMC, and Olympiad type of exams. And this angle, which is the related acute angle, is being calculated, which is same as that angle. So from here, we clearly see that tan theta, or tan beta I should write, is square root 3. And this gives you that the beta, the angle, is 60 degrees. Now this angle is 60, so that is also 60. And clearly, the angle theta is what? Well, the angle theta should be 180 degrees plus angle beta, right? which is 180 degrees plus 60. And that gives you the answer as 240 degrees. One of the options is 240, which is option C. So that is the angle which we finally found as the answer. So you understand how we have done this question. We have completed the solution using the special triangle whose measurements are 30, 60 and 90, right? Let me redraw the triangle. So that is your triangle where this angle is 60 degrees. That is 30 degrees, right? And the sides are 1, 2 and square root 3 is the opposite side to 60. Adjacent being 1, hypotenuse is 2. So that helps to get the solution of the question in hand. So I hope it makes sense. So this concept will be taken forward to solve and answer the two questions based on the rotation. Does that make sense to you? That is how we should understand a concept and see where, when it is to be applied. I hope that makes sense. Well, feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. So you can actually now solve these two questions and write down your solution. In the next video, I'll discuss at length the solution of these questions also. But I hope the concept which we have learned while getting the principal angle in the given solution, in the given problem, is absolutely clear. Well, feel free to write your comments, share your views. In case you like and subscribe to my videos, that'd be great. And you can always contact me on the email address given to learn more and consistently perform well. Thanks for your time and all the best.